This is the Math 1113 Zoom meeting for November 17th, 8 a.m. This is the last week of full assignments. No quiz this week. We'll have test 4 on Friday, due Sunday, covering 7, 1, 2, 3, 4, and 5 in the same format. Practice prize non-proctored test. Practice problem 7-4. This 7-5, page 610, we get this. On WebAssign, problems 1, 3, 4, and 5 only, and in section 7-5, 1, 2, 5, and 6 only, and just email me the percent of these 8 problems that you get correct. 7-5 will be about 7-4, and then 7-5. 7-4 will be about solving equations. 7.4 basic trig equations. Seven five has some more advanced ones. More advanced trig equations. So basically you 7.4 you solve by undoing. Some you can do in your head. Do in your head. Let's try example 1. Solve sine theta equals 1/2. All right, you're basically finding the angle with y coordinate 1/2. Find angle theta with y coordinate 1/2. And usually we think once around the circle, once around the circle, basically is 0 to 2 pi then. Usually these are done in radian mode. So if you draw it out, the y coordinate was 1/2 at, you can think 30 degrees if you want, but that was at pi over 6. So that gives you your first number. Your calculator will not give you that direct fraction. The other spot where you're at pi over 6 is over here. And again, that y coordinate will be 1/2. The x coordinate is √3 over 2. We don't really care. That would be if you were doing cosine of theta equals √3 over 2. The answer would be the same. And so you're pi over 6 short of pi. Short pi, so that means you're at 5 pi. So these are the 2 basic answers in 0 and 2 pi. Now, if the directions say find all answers, then we add on multiples of 2 pi. Usually use k for an integer. Okay, so I would write all answers, all solutions. Theta would be pi over 6 plus 2 pi k. Theta would be 5 pi over 6 plus 2 pi k. Now, that is where the book gets this, but they write it 2k pi. I don't know why. I prefer 2 pi k. 2 pi k is an integer. K, they're not telling you this, but k is 0, 1, 2, 3, blah, 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 blah. So at every multiple of 2 pi, you come back to the same two spots and you have an answer. In effect, you have infinite answers. In other words, I could add 2 pi to pi over 6, would that be 12? 13 pi over 6. And the sine of 13 pi over 6 would be a half, or 0.5. Now, on the calculator, and they will give you some on the calculator when you solve, just to contrast it, you do or you undo with arc sine. And if it's a cosine, it'd be arc cosine, tangent, arc tangent. So you'd be taking arc sine of sine theta, arc sine of 1/2. All right, and then you can, and you want radian mode, which I'm not in. Enter. So I would do second sine 1/2, and I get 0.5236. And if I take pi over 2, pi over 6, pi over 6, that was the answer. Pi divided by 6, there's my 0.5236. Okay, so you're only going to get nasty decimals out of these if you use the calculator. You do not get the nice fraction pi answers that they want a lot. If you want the other answer, that's when you got to draw the circle. Your reference is 0.5236. Over here, you're at 0.5236. And your other answer would be pi minus 0.5236. .61, we'll call it 2.618. And if you take 5 pi over 6, 5 pi, divided by 6, there is your 2.618. So that's the parallel version of these on the calculator. But a lot of them are on the circle and they want these kind of answers. Okay. Why don't we work down through some homework. Page 605. Lost if anybody's not. Okay. So I guess we'll start with the first one. Number 5, sine of theta, √3/2. Again, this is the y coordinate. Now, they're not really saying if they want all solutions or... So I'm going to treat it, basically you want the y coordinate equal √3/2. Sketch it out. √3/2, then you'd be at pi over 3. Okay, and your other place would be reference over here at pi over 3. So theta 1, say, is pi over 3. And the second theta would be pi over 3 short of pi. In other words, pi minus pi over 3, that'd be 2 pi over 3. At pi over 3 and 2 pi over 3, you get this. If you wanted to check sine pi over 3 0.866, sine 2 pi over 3 .866. And if you take root 3 over 2, see that's putting pi over 3. This says root 3 over 2. Second, root 3, 2, there's your 0.866. So your answers are pi over 3, 2 pi over 3, and then they want you to write down root. When you plug those, the answers are those angles, basic angles. Now, all solutions, you'd write theta equals pi over 3 plus 2 pi k. Book probably writes 2k pi, and theta equals 2 pi over 3 plus 2 pi k. Let's look back. 7.4, number 5. Yep. They write 2k pi for whatever reason. 7.4, number 3. Actually, it's number 5. Pi over 3 plus 2k pi. 2 pi over 3 plus 2k pi. So they're having you write out. I don't make you write those out. I'm perfectly happy if you can write the two answers in front on 0 to 2 pi. It's sort of implied. Looking at the assignments, I think I had you skip 17 to assignments here. Let's see. So we went 5 to 15, and then 25 on down. Okay. Why don't we try something like tan theta equals 5. Page 605, number 15, tan theta equals 5. So this is not a circle. You want to find not a circle value theta where y over x equals 5, or y equals 5 times the x. The y leg 5 times the x leg. Okay, so you're going to be pretty steep. It's going to be a pretty steep angle. Your y leg is 5 times your x leg. And we want to know that angle. So you're going to have to go arctangent of tangent theta, arctangent of 5. These cancel. Arctangent of 5 1.3734. That's the first angle. All right, for your other angle, you'll be in the third quadrant. It's the only other quadrant with a positive tangent. Like you go cross quadrant, and again, you want this y leg 5 times the x leg, but this angle will be your 1.3734. So your other angle is going to be 1.3734 add pi. In effect, pi plus 1.3734, which comes up 1.3734 plus pi 4.515, we'll call it. Let's see if they went on and did the plus 2 pi k. This is 7.4, number 15. Oh, it's k pi. Yeah, with tangents, that's right. Remember, the period of tangent is pi. Of tangent equals pi, period of sine, cosine, 2 pi. So that's why you add on sine and cosine plus 2 pi k or k pi, but you add on k pi. So you have an angle of 1.3, so they're using 2 digits, plus k pi and 4.515 plus k pi. And if you look at number 15, they're not listing the second one here because apparently it will come up automatic. Yeah, with k equal 1, you have 1.37 add pi. So they're not listing the second one. They're not listing this one, but it would come up from this. In fact, I did it here, plus pi with k equal 1. This is the k equal 1 answer. Okay. I don't know if any of this is making sense to anybody or only to me. Let's find all solutions. Okay, so let's try some with more steps. Why don't we try 33, page 605, 33, twice cosine squared of theta minus 1 equals 0. All right, so we want to solve for cosine theta. That means twice cosine squared theta would equal 1. Cosine squared theta then is 1/2. Cosine theta would be plus or minus square root of 1/2, which is plus or minus 1 over root 2. When it rationalized, it's going to look like it's going to be a value on the circle. Your cosine theta then is going to be plus or minus root 2 over 2. Root 2 on top times 1, and then root 2 times root 2 is 2. Now we bust it apart. Take cosine of theta equal positive root 2 over 2. And then you play the same game. On the circle, that's going to be where your x-coordinate equals this. So you're going to be at pi over 4. So theta is going to be pi over 4. And then cosine, you want an x-coordinate positive, and so that's going to be down here. Again, where this is pi over 4. And you're going to be at 7 pi over 4. Pi over 4 short of 2 pi. On the next one, cosine theta is going to be at negative root 2 over 2, and that's going to be your second and third quadrants. Negative root 2 over 2. You're going to be at pi over 4 there. That's going to give you 3 pi over 4. And you'll have the other one down here. And again, that's pi over 4. So you'll be at 5 pi over 4. Now, whether they list all of these and tack on 2 pi k's on them, I'm not sure. But that's what I would come up with on 0 to 2 pi. It says find all solutions. Now, they may wind up taking 2 lowest ones and adding on 2 pi k. This is where things get fuzzy. Let's see. 7.4, it was 33. Okay. Oh, and they're tacking on a k pi. Because apparently, again, you can get all the answers with just a k. Yeah, it's 37. I'm sorry. 33. Okay, 33, they're doing the same thing. They're tacking on a k pi because apparently you get all the answers from just a k pi instead of a 2. I find that very confusing. I just like to write down the lead numbers. So they're only writing down pi over 4 and 3 pi over 4. I like to write them all down on 0 to 2 pi, even though it technically didn't say that, which gives you these. And apparently you can get it from pi plus k pi. That's very confusing. I find that very confusing. We'll try to be clearer on the test. Okay, when you start at 39 and on, they bring in factoring. Solve equations by factoring. These are problems 39 to 55. This is still page 605. Let's try 39. Tan squared theta minus 4. 2 cosine theta add 1. Comes up equal to 0. All right, well, they've already factored this for you. So you set this factor 1, factor 2, set each piece to 0. All right, so tan squared theta minus 4 equals 0. Tan squared theta equals 4. Tangent theta then would be plus or minus 2. That's not going to be circle numbers. Piece 2, this is piece 1. Piece 2 then, twice cosine theta plus 1 equals 0. Twice cosine theta would equal negative 1. Cosine theta would be negative 1/2, and that is off circle. I'll do this one first. If your cosine theta is negative 1/2, negative 1/2 there, you're at a reference of pi over 3 there. So you'd be at 2 pi over 3. And down here, you'd be at 4 pi over 3. Pi over 3 bigger than pi, pi over 3 less than pi. Over here, you're going to have to bust these up to be tan theta then equals 2. Theta would be the arctangent of 2. .1071. And again, for that one, you can do a 1.1071 be first quadrant. And again, tangent positive would be into the third quadrant. Tangents go cross quadrants. So again, this is 1.1071. So your second angle would be pi plus 1.1071. I can just take this and add pi. 4.2487. And then you got to play the same game with now 1, 2, 3, 4 answers. We'll check in the book, see how many they actually write down. If you want to call it B, tan theta negative 2. Theta again is arctangent of negative 2. Again, it's where your y leg is twice your x leg. So second tangent, negative 2, negative 1.1071. So in effect, you're down this way. In the fourth quadrant, and then your other would be 1.1071. You'd be at pi. That's first angle right off the calculator for that, and your other angle, would be pi minus 1.1071. Don't worry about the negative here. I know that's why I draw the pictures. Try to keep everything positive on the pictures. You got to go pi minus that space. If you keep this and go pi minus negative, then you wind up adding it back to this one. Okay, so you're going pi minus 1.1071, and that's a 2.0345, we'll call it. All right, so I'm getting theta equal 2 pi over 3, 4 pi over 3, 1.1071, 4.2487, negative 1.1071, and 2.0345. Let's check and see how many of those the book actually writes down. This is 39, 74, 39. Okay, they're writing down the negative one, they're rounding it up to negative 1.11, positive 1.11, 2 pi over 3, and 4 pi over 3, adding on a 2k pi. So I'm getting these front numbers, and they're not writing these two down because they'd be tacked on with the k pi, and then they're writing these two front numbers tacked on with 2k pi. Okay. Let's try 47. We'll make that our last one because we really should get on to 7.5. This is when you're going to have to factor. So page 47, solve. Cosine squared theta minus cosine theta minus 6 equals 0. Hope you recognize your pattern. It's x squared minus x minus 6. And you'd be going x minus 3, x add 2. Two numbers multiplied to negative 6 add to negative 1. That'd be negative 3 plus 2 is your negative 1, and negative 3 times 2 is your negative 6. So we're going to get the same pattern, but we're going to have cosine theta where the x is. Cosine theta add 2. And I think you're going to find some things strange here. This would say that cosine theta equals 3, just like you'd have x equals 3 and x equals negative 2. And here you're going to have cosine theta equals negative 2. Well, these are clearly non-circle values, and this is where you got to remember rules about sine and cosine. Always less than 1. These are bigger than 1. Well, if you know the sign and the absolute value bigger than 1, it's going to have no solution at all. You can see if you go theta is arc cosine of 3. Just even punching it makes the math gods me. Oh, okay, so arc 3, error. On the other one, you'd have arc cosine of negative 2. I don't know why they give you one with no solution. Negative 2, nothing. Let's check the book. Let's see, this was 47, 7.4.47. I don't know why I can't keep a page back here because I'm not real bright. 4.47. Oops, next page. No, 7.5, 7.4. 47. No solution at all. Right there. Yeah. The factoring just doesn't come out with a sign. You'd have a solution with tangents if that was a tangent, but wouldn't make this a sine. You still have no solution, but make it a tangent, you would. Okay. Let's go on to 7.5. We can get some problems in about that. And you just have more equations. Where you have to play games and use identities. You have to use identities to solve equations. You just have to use whatever you need at the moment. Okay, let's see. Why don't we try example 1? Solve. 1 plus sine twice cosine squared. Okay, you want to get all in one function. And you'll never convert sine to cosine, but you can convert this to sine if you remember that cosine squared is 1 minus sine squared. 1 plus sine is equal to twice 1 minus sine squared. So 1 plus sine, distribute the 2, 2 minus 2 sine squared. If we can bring these pieces over, you've got 1 plus sine minus 2, add 2 sine squared. And we can write that 2 sine squared plus sine minus 1. And I'm guessing that this factors. If you remember how you play the game, you've got a 2 sine theta. I'm just putting this in. I got to FOIL back to see if I get it. And then sine theta, I must say minus 1. I'm not looking at the book to see what I get. 2 sine squared. I'm getting a minus 2 plus 1. No, so you got the signs backwards. It should be this way. 2 sine squared plus 2 sine minus sine gives me a positive sign and then a negative 1. So 2 sine theta will equal 1. Sine theta 1/2. I don't know if you can do these off the circle now, just to speed things up. Sine theta 1/2, you're going to be at pi over 6 and 5 pi over 6. Over here, sine theta equal negative 1, and you're going to be down at the bottom, 3 pi over 2. And they tack on a 2k pi to all those numbers. That's what they have. They tack on a 2k pi. To all those. Okay. Why don't we try some, might as well just try some homework ones, try to help you out with the homework. Let's see, number 3 will be pretty similar to that. Let's try one with a double angle like number 7. So this is 7.5, page 610. Number 7, sine 2 theta, 3 sine theta equals 0. And when it's solved. If you remember your double angle, sure you have this right on your brain, just like I do, a sine of 2 theta twice sine cosine. Sure you have it perfectly memorized, just like I do. Put that in. Cosine theta minus 3 sine. You want to factor out the common factor. Sine theta twice cosine theta minus 3. This is going to give you sine theta equals 0. And 2 cosine theta will equal 3. Cosine theta would be 3/2. See, that's greater than 1. This has got no solution. Over here, you basically have 0 at pi and at 2 pi. Sine theta being 0, you're here, this is 0, this is pi, and then you're back to here, you're at 2 pi. So it's a matter of reading what you have and knowing what identity you need to use. I know it's easy for me to say. I've only been teaching this 32, I'm in 33rd year. Let's see. Why don't we try one like 17? Where's my assignment page? Sure. Assignment page. Here we are. We went 3 to 33. 3 over to 33. Okay. I left off the last half. Don't thank me all at once. I got time for maybe a couple more. About 17. 10, solve. Cosine 3 theta equals 1. Okay. This is going to get nasty a little bit. We're basically going to concentrate on in A, they want all solutions. In B, they want them on 2 pi. Note that's a parentheses. They're using a parentheses. Notice they're not including 2 pi. Hope you remember your interval notation. Notice the parentheses there. It's technical. Where am I? Let's see. 17. 17, the directions, they're including 0, but not 2 pi. Okay. This means that cosine of 3 theta then would equal 1/2. Now, if I had cosine theta equal 1/2, I'm at pi over 3 and 2 pi over, I'm so sorry, it's 5 pi over 3. 5 pi over 3. Draw it out. You're at 1/2 on the x-coordinate. That would be at pi over 3. Down here, you'd be pi over 3 short of 2 pi, 6 pi over 3. You'd be at 5 pi over 3. So this is 5 pi over 3 and pi over 3. And you're done. But you don't have a plane theta. You've got a 3 theta. This is going to divide answers by 3. So meaning my first cut at it will be 3 theta equal pi over 3. Instead of having a straight theta equals pi over 3 and I'm done, I have a coefficient on the 3. So it's at the same spot. This kind of blob has got to equal pi over 3. But now I divide by 3. You get pi over 3 times 1/3. You get pi over 9. Your angle, pi over 9, your angle is a third bigger, thirds times it. It's got this factor of a third in it, which divides it down. This is going to give you roughly 3 times as many answers. 3 times as many answers on the same interval. On the same 0 to 2 pi once around the circle. You're going to get, because you're dividing the answers down by that coefficient, that's going to give you that many more answers than you had on the straight interval with the straight theta. All right, my second cut at it is that 3 theta equals 5 pi over 3. And you can see what happens here. Theta is going to be 5 pi over 9. Now, part A, all answers, they may be tacking on a 2 pi k or something to these. But let's just keep going. Second around, my next cut at it, I'm at 3 theta and it's equal to pi over 3, but I've added 2 pi. So I've come around on it again, which means I have pi over 3 add 6 pi over 3, which is 7 pi over 3. when I divide by 3, I'm at theta equals 7 pi over 9. You got to know where you are on the circle here so you know when to quit this madness. See, 9 pi is equal to 9 pi over 9. So I'm in the second quadrant, just short of pi. I'm barely halfway around. I'm not even quite halfway around. All right, next cut at it. I'm at 5 pi over 3, add 2 pi. You can tell that's 11 pi over 3. See, this is 6 pi over 3. So 6 pi over 3, add pi over 3. I'm at 11 pi over 3. Theta would then equal 11 pi over 9. And now I'm just 2 pi over 9 bigger, so I'm into the third quadrant. So I got to keep going. Fifth quadrant, or fifth cut at it, 3 theta would equal, now I could either take these cut at another 2 pi over 9, or I could take the original pi over 9, actually pi over 3, and I'm adding 4 pi. You play it however you want, and 4 pi, putting over 3 would be 12 pi over 3. So I'm at pi over 3, add 12 pi over 3, which is 13 pi over 3, and theta then would be 13 pi over 9. How do I know when to quit this madness? 2 pi is equal to 18 pi over 9. I'm not quite there yet. 6 cut at it. 3 theta would be 5 pi over 3, add 4 pi, which is 12 pi over 3. So that's 17 pi over 3. Theta would be 17 pi over 9. I'm almost at 18 pi over 9. I'm still less than 2 pi, which is 18 pi over 9. But if you can tell, the next one's going to throw you over. So part B, I'm at pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, 17 pi over 9. This is 7.5, number 17. Okay, part A, they're taking those original pi over 9s. Let's see over here, 17, 7, 5, 17. Okay. And adding 2, it's 2 pi. That's why I don't like, it's 2k pi over 3, because you're dividing the answers by 3. I have a hard time figuring that out. So I never really make y'all do that. But here is your pi over 9, 5 pi over 9, 7 pi, 11 pi over 9, 13 pi over 9, and 17 pi over 9. Okay. I'm at almost 50 minutes. That's a pretty good introduction to everything. I think we'll go ahead and end the meeting. Hope to see y'all on Thursday.